Graphing complex numbers. So a complex number has both a real and an imaginary portion, or can have one of the two. So when we're graphing on the complex plane, the real is the part that doesn't have the I, and the imaginary comes from the part with the I. We're going to treat the imaginary like it's the Y and the real like the X. So if we look here, we have 5 as our real portion. So we're going to come over to the 5. 1, 2, 3, 4, 5. As that means it's somewhere on this line. The 2I tells us we're going to go up 2. And so our dot, or our location, is here. And these are just going to be single ordered pairs. So there's just going to be a single dot as your answer when you get these done. So if we look at this next one, our real portion is -2. 1, 2. Our imaginary portion is -6. Or -7, excuse me. So I'm going to go down 1, 2, 3, 4, 5, 6, 7. And so there is going to be my dot for my ordered pair. I'm just putting the hashed little lines to help you see where I'm counting to. And so that's the only thing that's my solution, is where that dot is. So let's look at the next one. So our real portion is the 5. Our imaginary portion is the -2. So I go over 5. 1, 2, 3, 4, 5. I'm going to go down 2, 1, 2. And that gives me my dot here. So I want you to do the next one and see which one of the graphs would give you would be graphed for that complex number. Okay, looking at number 4. There's only a complex portion, or there's only an imaginary portion on this one. That doesn't mean the other part doesn't exist. It's the same thing as 0 plus 6i. So if the real or imaginary part is vacant or is missing, it's going to be on the axis. So we're not going to go left and right any. We're going to go, but we are going to count up 6. 1, 2, 3, 4, 5, 6. And that's where I'll put my dot. And so that is my answer. Operations with imaginary numbers. Today we're going to work with addition, subtraction, multiplication. We are going to wait for division for the next 2 days. But for the most part, imaginary numbers get treated like it was just a variable, like x. The only thing that we do different is we cannot leave an imaginary number to any power. So you have to simplify it like we did last week. So if you have a I squared, it becomes -1. I cubed becomes -I, and I to the 4th becomes 1. And so we're going to, anytime you end up with a power on your imaginary number, you need to go back and simplify it down to no powers on it, or then 1 or -1. So let's start off. On this one, we have 3 groups of imaginary numbers. And we are looking at trying to figure out what would this combine down to. And when we write imaginary numbers, we always write it as A plus BI. That means your real part of your number gets written first, and whatever is imaginary gets written second. So this negative sign is going to distribute to both parts. This positive sign, the plus sign, is going to distribute to both parts. So the next line would be 3i minus 2 minus a positive 4i plus 6, and we're adding a positive there, plus a -2i. And so you don't have to write this step. If you want to just go ahead and simplify the signs as you go to the next step, you can. And that gives us 3i minus 2 minus 4i plus 6 minus 2i. And at this step, if you had any powers on your I, you would simplify those first. And then we're going to go into combining our imaginary parts and our real parts. And so our real part is anything without an I. So we have two real parts on this one. So we have negative 2 plus 6i, or plus 6. Negative 2 plus 6 is 4. Now we're going to look at our imaginary portions. And so our imaginary portion is anything with an I. So we have 3 minus 4 giving us negative I, minus 2 giving us a negative 3i. That's your answer. So when you're adding and subtracting, it's going to be very similar to combining like terms we did back in 7th and 8th grade. It just, only thing you have to watch for is if when you multiply something in front of it, if it changes any of your powers of I. And then you need to simplify those first and then combine like terms. So let's look again. I want you to do this one on your own and check your answer using the Edpuzzle. Next thing we're going to look at is multiplication. And on multiplication, you can use FOIL, or I like to use the box method, just like we were using the box for factoring, but when we're multiplying, we go from outside in. And so we're going to put our factors on the outside, so it's negative 2, positive 5i, 4, minus 3i. And so we're going to multiply to create the box. So negative 2 times 4 gives me a negative 8. A negative 2 times 3, negative 3, gives me a positive 6. I times nothing is just going to give me an I. And then we're going to do the next column the same way. So you're going to do 4 times 5, giving you 20. And then the I, there's only one of them, so 20i. And then we're going to do the last spot, which is 5i and negative 3i. So 5 times negative 3 gives me a negative 15. I times I gives me I squared. I squared is the same thing as negative 1. So let's go ahead and simplify that. 15 times negative 1 is a positive 15. So now we're going to combine like terms, and you should always have these be alike and these alike. So if you do not, go back and check and see what you did wrong. And so when we combine our first diagonal, negative 8 plus 15 gives us a positive 7. Our second diagonal, 6 plus 20 gives us 26. And again, we need it in the form of the real portion, the part without an I, and then your imaginary portion. And that's your answer. Let's look at this next one. This next one's going to have a few more steps because we need to figure out what it is when we actually multiply that out, or what we're actually going to be multiplying out. So we're going to need to figure out what the two sides are going to be. This is the same thing as me writing it as negative 1 times 2 minus 3i times 2 minus 3i. So that means on the outside, I'm going to have 2 and negative 3i, 2 and a negative 3i. And so we're going to multiply outside in again. And so 2 times 2 is 4. 2 times negative 3 is a negative 6i. 2 times negative 3 is a negative 6i. And then negative 3i times negative 3i gives me a negative 9i squared. Convert that to a negative 1. Negative 1 times 9 is a positive 9. So that gets written as a positive 9. Look at your two diagonals. And we're going to simplify those and write them. That negative 1 just hangs out at the front until the last step, and we're going to multiply it through everything. So when we combine our real portion, we have 4 plus 9, which is 13. So this portion is 4 plus 9, and that gives you your 13. Then our imaginary portion, negative 6i plus a negative 6i is going to give me a negative 12i. And the last step is we're going to take that negative 1 and distribute it to both parts. So that gives me negative 13 plus 12i. And let's do this next one. So this is where we want to figure out what is this one term first, and then distribute it through to the second parenthesis. So first simplify what doesn't have, when there's just one portion of it, and that's just going to multiply. So negative 2 times 3 gives me negative 6. I times I gives me I squared. Before I go to the next step, I need to take and simplify that I squared. I squared becomes negative 1. Negative 1 times 6 gives me a positive 6. And then we just work with what we had originally, that 2 plus 7i. So you don't need a box on this because it's not two binomials. We'll just go ahead and distribute that 6 through to both parts. And we have 12 plus 42i. And we have it in the format of real then imaginary. So I know it's in the right format. And then, I forgot to write the problem, but here it is. You have 7 minus 6i times negative 2 plus 4i. And I want you to go ahead and multiply that through and check your answer using the Edpuzzle.